Hi everybody, so I'm going to work on the Solids Mastery Review. As a reminder, you have access to all of these at all times. So all of these formulas we will be using and all of those conversions if necessary. So starting with the first one, we're just determining the volumes of all of these shapes. So you need to be able to look at this and know that it's a triangular prism. As a reminder, prisms are named by their bases, which is an important fact. So this triangle is what's repeated across this whole shape. The reason that's important, because if you look up, that's not good to see. Let me try a black Sharpie. Well, that you can see way better. Let me get this to stop rocking. Okay, this is the formula for any prism. It's the general prism formula. It's what you have on there. What you need to understand at this is the area of the base. So in this case, that area is 1/2 the base times the height of this triangle. And I know that this is the base and this is the height because, as a reminder, they're always perpendicular to each other. So 6 and 8 are the base and height of the two-dimensional triangle. This height is the depth of the object, or the height of the prism, which is 12. So from there, I can just type that entire thing into the calculator. So as a reminder, I would hit, I just hit something that I didn't want to hit, just Control Divide to get my fraction up there. And then I can just type in 1/2 times 6 times 8 times 12. Just type that whole thing in, and 288. And that would be feet cubed in this case. Volume is always cubic, and these are all feet. Moving on to the next, this is a cylinder, but remember it's kind of laying on its side. The cylinder formula, again, is on that formula sheet. The volume is pi r squared h. R is the radius. Looking at the picture, I need to realize that I have the diameter, so the radius is half of it, which is 1. And then the height is, again, the depth. It's just laying on its side, so 5. You might have been thinking 2 was the height. Nope, remember, a cylinder, I can redraw it any way I want to, but it's always considered the height like that. So this would be 5 pi. Now notice it says exact answer. That means I would be doing it in terms of pi, so I would just leave it as 5 pi. If it said to round to the nearest whatever it might be, I would hit 5. As a reminder, the pi button is down here next to the letter H. Hit enter, and I would have 15.7 yada 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 yada. And then I'm assuming it would tell me to round to the nearest 10th in that case, which would be 15.7, but you would round appropriately. A cube is technically a general prism, so again, this would be the formula you would start with, but it's really just length times width times height. And with a cube, all of those are the exact same. So this is simply 3 times 3, so that's the area of this square base, and then 3 is the height of the prism itself. So 3 times 3 times 3 is 27 centimeters cubed. I'm sorry, I should have had centimeters cubed on that one as well. Then we get into what are called composite shapes. Now that's when you have to realize that you have two shapes stacked on each other, or a shape subtracted from another shape, like a hole. So here I see that I have this piece that I need to join, okay? I have 8 here. This part is 9. Okay. So I'm just gonna rewrite the 9 because I drew over it. Remember, those symbols mean congruent, which means this is 8 and this is 8. So this entire length, which is equal to this entire length, is 16, and 9, which is 25. Okay. Again, this is 8, and then I know that this is 7. Okay. This 7 will correspond down here because those are both the depths of the object, and then the 17 is this height. So I have 2 prisms, so I need to do base times height plus area of the base times height. Remember, capital B is area of the base times height. For my rectangular prism, this is easy peasy. It doesn't matter which way you look at it, this rectangle is being multiplied by the depth. So 7 is going to be that height in both cases because the 3-dimensional objects have the same depth. From there, this rectangle has 8 by 25 as its base and height. And then the other shape is a triangle, so I need to do area of a triangle, because remember, when you're dealing with a triangle, your area is 1/2 base times height, and that's what goes in for area of the base. So the base of the triangle is 9, the height of the triangle is 17. So that's where I get those numbers from. I squeeze them in there just fine. And then I simply multiply all that through. So I have 8 times 25 times 7 plus 1/2 times 9 times 17 times 7. Add it all together, I get that lovely thing. Now, more than likely, it wouldn't ask for that as your final answer. So let me just write that down really quick first. So as a reminder, to switch that to a decimal, you could just scroll up, highlight it, and put a decimal point next to either the numerator or the denominator. It doesn't matter which. So I get 1,935.5 centimeters cubed. On the right, I have a trapezoidal prism technically, but I'm gonna go ahead and cut that into a rectangle and into a triangle so that I can deal with those. And then I need to subtract this cylinder because there's a hole in it, so I need to subtract that cylinder out. So I will be having, the volume is going to be area of the base times height plus area of the base times height minus pi r squared h. So this is my rectangular prism, this is my triangular prism, and this is my cylinder. So volume equals, for my rectangle, this is 9 by 7 by this depth, which is the same as the depth over there, which is 6. So 9 times 7 times 6 will give me my rectangular prism. Plus, again, because it's a triangular prism, I have 1/2 base. So if this is 9, this is 9, this whole thing is 18, so I know that that is also 9 now. So base times height, the height is equal to this height, so 7, times the depth of the object, which again is 6. Okay. I'm going to do that out just because I'm running out of space, but I still need to subtract the cylinder. So let's just get that volume first right now. So 9 times 7 times 6 plus 1/2, 1/2 times 9 times 7 times 6. Just so happens that they were almost identical shapes. Okay, so 567, but I still need to subtract the cylinder from that, so pi r squared h. It tells us here d equals 4, that means the diameter is 4, therefore my radius is 2. And the height of the cylinder, now you gotta realize, this cylinder is technically going like this through the object, okay? So this height is the same as this height, so that is still 6. So now I'm going to type that in, so I can highlight that and hit minus pi 2 squared. Oh, but notice it says E, so give me 2 seconds to finish typing this in, then I'll show you how to fix it, if you realize it after the fact like I just did, times 6. So that's 491.60177, etc. But again, it wants the exact value. So that means in terms of pi. So what I'll do is I'll just go right back in there, and I'm going to erase this and erase the pi, because I can't just subtract them because of that pi. So this is 24 pi, and this is how I would leave that as an exact answer in this case, because 24 pi I couldn't do 567 minus 24 and then times pi. It's kind of like an x, they're not like terms. So you would just leave it at that if it wanted in terms of pi. Otherwise, you would have this decimal up here, and then you would round it wherever it told you to. On the back, this is bleeding through because of the Sharpie, but we can deal with it. On the back, we have this shape. Now, this is what's referred to as a slant height. Anytime you have that slant height, you need to realize that you need Pythagorean theorem, because you have this right triangle right here. Okay, so the slant is always the hypotenuse, and then you usually have to work backwards for the height, which I'm going to call x. So that's where this part comes from. You're going to go through and solve for that. Once you solve for this, this is simply v equals 1/3 pi r squared h, because that's a cone. This is the formula given for a cone. And you would then substitute 1/3 pi, your radius is 8, and your height is the number you get when you solve from the Pythagorean theorem there. You would not type pi into the calculator because you would leave it in terms of pi. I've already gone over all of that and shown you how to type it in, so I'm just explaining how to do that one. For the square pyramid, okay, square pyramid, so that tells you if this is 10, this is also 10. A square pyramid is another place where you can have a slant height. So again, in order to find the actual height of the pyramid, I need to go through Pythagorean theorem. So 13 is the hypotenuse. Notice this entire distance is 10. So this leg of my triangle is actually 5. And then I'm looking again for the height. Once I have that height, this is the formula I'm given. I would have just solved for this. Reminder that this is area of the base. So in this case, this is 10 times 10. And then again, the height came from the Pythagorean theorem moments ago. This is just another way that they could randomly decide to give you a Pythagorean theorem question. Just pointing out that to find the diameter in this case, I would be using, again, x squared plus 8 squared equals 10 squared. I would solve, this one's one that I know, I would end up with 6. That one I would have ended up with 12. That one isn't one that I know. But so you would have gotten 12 for that one, just in case you're doing that on your own. So this whole distance is 6, meaning my radius is 3. It's a cylinder, so this is simply pi radius squared times height, which is 8, because that would be the height of the cylinder. Then we get into the word problems, which is where you're going to see this a lot on the Regents exam. Seawater contains approximately 1.2 ounces of salt per liter on average. So 1.2 ounces per 1 liter. How many gallons of seawater to the nearest tenth of a gallon would contain 1 pound of salt? So we need to get this to gallons. So this is a conversion problem and only a conversion problem. So we 100% need to use all of this stuff. Okay. So I have liters and I have ounces. I need to get to gallons somehow. So I'll find gallons. I have gallons in quarts. I have gallons in liters. Oh, right there is what I need. Okay. So per liter, 1.2 ounces of salt per liter on average. How many gallons of seawater to the nearest tenth of a gallon would contain 1 pound of salt? So I also need to get it to pounds. Okay, so here I go. I'm going to start with that first one that we just talked about. I need to get rid of liters. So it said 1 liter is 0.264 gallons, or I have 1 gallon is 3.785 liters. I could use either one I want. I just need to make sure that I put the liters on top because I need the gallons to stay. And by putting the liters on top, it will cancel out. So I'm going to use 1 gallon is 3.785 liters. And now I need to cancel out my ounces with pounds. So go in here, 1 pound is 16 ounces. So again, I need the ounces to cancel, and I need to keep the pounds. So now my ounces cancel. Notice I'm now left with pounds per gallon. So to the nearest tenth of a gallon would contain 1 pound of salt. How many gallons would contain 1 pound of salt? So I'm getting there. I'm on my way. Okay, 1.2 times, because it's on top, 3.785. Enter, and then I'm going to divide that by 16. Okay, so I now have 0.283875 pounds per gallon. And I want this to be 1 pound. So now how can I make this into a whole pound, basically, right? So you gotta, it's not really one that I can just explain necessarily. This is one that you kind of have to think through. But I know that this many is in 1 gallon. Okay. So if I multiply each of these by it, that will help me get the pounds. So I could do process of elimination. So I could do 3.3 times this conversion that I've created, 875. And I get really close. I get 0.9. So that's kind of close. I'll write that down next to it. I'll go up and copy. I'll change that to 3.5 now. Ooh, and I get 0.99, so I'm even closer to 1. If I change that to 4.7, I'm going to be way too high. Hopefully you'll realize that. And then same thing with 13.3 is definitely way too much. So that's why it's going to be choice 2 for this. There are going to be other right ways to get the answer. That's just the way my brain took me on it this time when I did it. Okay, Molly wishes to make a lawn ornament in the form of a solid sphere. So automatically I'm going to go to my reference sheet and write this down. I cannot tell you how important it is to read your reference sheet appropriately and write it down appropriately. People write that 3 as a 2 all the time. It's not a 2, it's a 3. Okay. The clay being used to make the sphere weighs 0.075 pounds per cubic inch. If the sphere's radius is 4 inches, what is the weight? So this is just going to be a straight up calculate the volume and then multiply by the density. So I'll type in 4/3 pi 4 to the third, not squared, and I get that 268, and then you just multiply volume times density to get your mass. So 20.106, so 20, because nearest pound. Last question. Hunter runs a general store. He gets a new cylindrical cup. So I'm going to draw that cylinder with a diameter of 6 centimeters. So I usually just jump right to the radius in my pictures, but you can do it however you would like to. And a height of 11 centimeters to fill the 2 kilogram bag of sugar. So I should have said bag. Or no, he's got a cup and he's filling up the bag with 2 kilograms. The density of sugar is 1.60. How many cups will it take to fill the bag? Round to the nearest cup. So first thing I'm going to do is double check centimeters. Centimeters, I'm good to go, but please remember to always check that. So this is 1 cup. Again, I'm going to start with my volume, pi r squared h. And now I'm going to type that into the calculator because I can't do pi in my head. I don't think, I mean, you can approximate pi in your head, but that's not a thing. Times 11. Okay, 311. And I'm not rounding yet because I'm not at the end, and I don't round it to the very end. Now I do round when I say go 4 decimal places. If you look at the calculator, you'll see I have a 6 there, but a 7 next to it, so I wrote it as 7. That's what I mean by going 4 decimal places. It means I'm going to round that one. So this is currently centimeters cubed. And I need to know how many it's going to take to fill up the 2 kilogram bag. So this is going to be an ugly situation here, but they do tell me that the density of sugar is 1.60 grams per centimeters cubed. So I have 2 kilograms, and then I know that I have this situation happening. So I need to quickly remember that this says grams, not kilograms, and I need to convert that aspect of it as well. So I'll show you what I mean as I write this out. So I want to cancel out the kilograms, but I can't just yet because I have grams per centimeter cubed. So I need to quickly throw in a 1 kilogram equals 1,000 grams. That one will not be found on your reference sheet. That's one you're expected to know. So 2 kilograms, I can switch that to grams. So that's 2,000 grams. And now I can use this conversion. Again, I'm putting grams on the bottom because I want my answer in centimeters cubed, so that will cancel out. So 2,000 divided by 1.6 is 1,250 centimeters cubed. I want to know how many of these it takes to fill that, so I'm going to divide. Divided by, there's a glare, sorry, 311.0177, 4.019, etc., etc., etc. And now finally, how many cups will it take to fill the bag? Round to the nearest cup. Because it says round to the nearest cup, this isn't one of those tricky, oh, it's going to take 5. They mean, right, we're not going to overfill it. So just 4 cups would be your final answer. And that's how you would get through that problem. So that is solids. I hope it helped. The biggest thing I could say is you need to remember that means area of the base. Have a great day.